This question gives us a function, and they say for this function, there are four important intervals, A, B, C, breaking them up, where A, B, and C are critical numbers. So critical numbers, we find those by finding out where the derivative is zero. So let's take this function, and let's take his derivative. So the derivative, here we go. The 5 comes down. That'll be 60 x to the fourth if you subtract 1 from the power. The 4 comes down. 240, subtract 1 from the power, x to the third. The 3 comes down, minus 300, subtract 1 from the power, x squared, and the 3 is just 0. So there's the derivative, and we want to set it equal to 0 because we want to find out where's the derivative of 0. Those are the critical points. Well, we should factor out the 60 and the x squared. This will leave x squared plus 4x minus 5. Just check that in your calculator. I just take 60, 240, and 300. I notice that 60 goes into all of them. You can double check in your calculator. And I take out the lowest power, x squared. See, this would work. If you multiply this, go back to x fourth. Multiply this 4 times 6 is 24, 240. 1 power and the 2 power add to be 3. And then these multiply. 5 times 6 is 30, 300, x squared. So it's right. And so now let's leave that 60x squared in front. And then this is going to factor, remember like FOIL, FOIL, front times front to make front, x times x. And then last times last in the two parentheses to make 5. That's 1 times 5 or 5 times 1. The order doesn't matter, but the signs do. You got to both no, sorry. The sign in the middle always goes on the bigger plus, and that's minus. So that's plus 5 minus 1 makes plus 4, and they multiply to be negative 5. So there it is. And now and remember, so this is set equal to 0. These three things are multiplying to equal 0. So logically, that means that the first one is 0, or the second one is 0, or the third one is 0, right? If three things are multiplying to be 0, any one could be 0 to make that true. Divide by 60. X squared is 0. Root it. You do plus or minus if you want. Doesn't matter. It's just going to be 0, plus or minus 0. Move that over. Move that over. Plus 1. So we got 0, plus 1, and negative 5. So there's our three critical values, negative 5, 0, and 1 in order. And then they want us to figure out which of these are, where do we have local mins and maxes and stuff? Well, to figure that out, we gotta look at the number line interval thing. Put them in order again, so we're gonna go, okay. Um, Put them on there, and this is, what's the first one? Negative 5. X is negative 5, x is 0, x is plus 1. Then we got to pick things in each one. So this is, well, this be like negative 6, check x equals negative 6, check that left interval. This one I could check x is negative 1. Here I could check x is positive 0.5, half. And then over here, x is 2. Check each other. Check what? Check the first derivative, which is this function right here. 60x to the fourth, so the first derivative, 60x to the fourth, plus 240x cubed. That's a third power there. And then minus 300x squared. Okay, so I'm going to check by plugging in negative 6 everywhere. First up, f prime equals, let's plug in negative 6. Let me think it's right there. There it is. I've already got it. Typed in, plugged in negative 6, got 15,120. 15,120. Positive 15,120. Let's do the one in the middle. We're going to plug in negative 1 now. So make that 6 into negative 1. And we get, here we go, negative 480. Negative 480. So far it's going up Increasing, that's going down, decreasing. Okay, now plug in x is positive 0.5. Um, come on, 0.5. I get negative 41.25, negative 41.25. So that's decreasing again. That must be further decreasing, right? And finally, plug into 2, 2, 2. I'm getting 1680, positive 1680, positive 1680. So it's increasing. It's coming back up. Okay. So now they're going to ask me where are the local mins and maxes and stuff. Well, right here, this must be a max. So that's negative 5 is a max. This guy must be a minimum, which is positive 1 must be a minimum. So negative 5 is a max. Oh yeah, this is A, B, C. So A is a max, C is a min. Yeah, this is A here. A is a max, linear L max, linear max, a local max, I mean. C is a local min, as we said, and B is neither. See, B is just, it just keeps going down. It's actually a point of inflection. It's neither local max nor local min. And so there we go.